this again. Okay, I'm going to have a special Sunday Easter edition of the stream here, and we will look at grounding and jumping. So if I have a character in my game, and I want to make the character jump up and down. Hey everybody, how are you doing? Over here I am in the exciting, over here in the corner. I'm going to, let's see. Is that my live? That's my scene. Okay, I'm going to go ahead and I'm going to hide myself here. I just wanted to say hi. I'm still alive. So turn that off for a moment. All right, so we have our game, and we have this squirrel. And the squirrel, the idea is that the squirrel can move left and right using the joystick or using the horizontal axis. And I'm using actually keys A and D to move left and right. And W and S don't do anything at this point because there is no up and down. But what I want to do is I want to add something to allow them to jump. So if I hit the space bar, the squirrel can jump. Now, there's a couple of things about that jumping behavior that's interesting. You'll notice the moment I jump, I can only jump straight up. Or if I was running along, I could jump and I have some momentum. Whoops, there, be careful. And once I start jumping, I can't continually jump. So if I was hitting the space bar continuously, it only jumps when I'm touching the ground. So this idea of being grounded, we often call it here. So how does this player know when he's touching the ground? All right. Now, the animations are set up fairly normally. If we look in the animator here, we'll see we have a squirrel idle state. We have the squirrel running state, which is controlled by whether or not the squirrel has X velocity. But you'll notice we have this new thing. We added another parameter called grounded. And grounded is a Boolean. And you'll see if I jump, suddenly grounded becomes false. And if I do jump, and I'm trying to hold A or D, you'll notice my velocity also suddenly freezes. Whoa, poor squirrel. And that is because he's not grounded. In order to move, in order to go back to the idle state here, if grounded has to be true in order to be idle, and grounded has to be true in order to run, right? If grounded is not true, it goes from any state to this jumping state, right? So if it's not touching the ground, which is basically, if I come over here and I look at my branches here, I have a couple of branches that are on this ground layer. All right. So they have to, there's something to do with, that's the hint, I have these box colliders and I have them on the ground layer. Now the squirrel itself is on this default layer. So the squirrel is a lot like the hero. Maybe the squirrel will become our hero. And so if we look at the squirrel in the scene here, you'll see the squirrel. There's his origin. That's his eye level there. And I temporarily put this game object on the squirrel here just to show that down here by his feet, if I wanted a game object there, that would be at an offset of negative 1.22. That's about where his feet are down here. Right. Now, I'm not actually going to use this game object for anything. I'm just using that to illustrate the point that his feet are offset by 1.22 from his center. Okay, and that's the important part. All right, so the squirrel has a rigid body 2D, it has a capsule collider, and it has the squirrel controller. Now, if we watch the squirrel controller, and we see this grounded over here, you'll notice also, if I come over here and I jump, grounded is changing based on whether he's jumping. All right, so let's look in the squirrel controller. Now, so the squirrel controller has this public bool called grounded, and it's false by default, so it's going to be set according to some type of condition. All right, and what we're going to do is we're going to use something we used in another one of the lessons, which was to check a overlapping circle to see if the overlapping circle collided with any objects. Okay, so we create a circle, we project the circle into the scene using this physics 2D overlap circle. We put it at a certain position, and we give it a radius. Okay, now what I'm going to do is inside of update, what I'm going to do is use this physics 2D overlap circle, and I'm going to look at the position of my hero here, the mouse, the squirrel, use the position of the squirrel, and I'm going to offset that position by 1.3, which is about similar to that 1.22. It's a little bit more than that. So it's a position. This position is going to basically become a position that is underneath the squirrel, like right at his feet. And I'm going to have a fairly tight little circle there. Okay, so there's a little circle of radius 0.2 at the feet of our squirrel. And I'm going to use this. I'm going to see, okay, what colliders does that collide with? Now, I have to be careful because one of the things it would collide with is the actual collider that belongs to the squirrel itself. And that's no good. We can't have the squirrel being grounded thinking that it's touching the the actual collider that it's got attached to it. So we have to somehow tell it, okay, don't pay attention to your own layer. Okay, look at any other layer in this case. I could have had it only look at the grounded layer if I wanted, but I'm going to say for now that that the squirrel is grounded as long as it's touching some collider that's not on its own layer. Okay. Now I do this by saying I create a temporary layer mask, and how I do that is I say, all right, the layer mask, I am going to take a bit. This is going to be a little bit of a bit manipulation here. So I take one bit and I shift it over according to the layer that this game object is on. Right. So if this object was on layer 2, this number would be 2, and I would shift this by 1. So if I shift 1 by 1, it becomes 2. If I shift 1 by 2, it becomes 4, and so on and so on. Okay, so it allows me to put a bit in a certain position in a field, and then what I do is I use this negation. Okay, and what this does is it's basically going to flip all of the bits except for this one here. So that means include in the mask, include in this mask everything except the one bit that corresponds to this layer. And it's the layer that this game object is on. So that's a little bit of magic here. Okay, so I create a layer mask that is all other layers except for the layer that this is on. Now, alternatively, if I wanted to create and have it only check for the grounded layer, I could do this. I will say I need layer to name. So let's see, can I say that layer to, I'm going to figure, I have to remember, how do I do this? Layer mask dot layer to name, or name to layer. There we go. Name to layer. That's better. And the name I'm interested in is ground. Okay. So if we look over in here and we check out that branch, the branch is on the, oh, capital G. Let's be careful about that. Capital G ground. All right, so this now is creating a layer mask that is only the ground layer. So I'm going to check to see, does this overlapping circle touch any collider that is on the grounded or this ground layer, right? And if so, it's going to return null if it doesn't collide with anything, or not null if it does. So if this overlapping circle does not equal null, that means yes, it has collided with some sort of collider that is on that ground layer. And in that case, grounded will become true. Okay, so when it becomes true, that means, okay, we're on the ground, we're allowed to do things like jump and run and so on. We're not in the air. So one of the first things I do with that is, of course, I need to tell the animator about it. So I just say, oh, transform.getComponentAnimator, set bool, because it's a Boolean value, and the Boolean value I'm setting over in the animator is called grounded, and the value I'm passing it also happens to be called grounded. These don't necessarily have to match, but that works out to how I named it, how I named the parameter in the animator, and named the field here within the class. All right, so now the animator knows about that. Then the animator will allow the transition to that jumping state or the other states. Now, you'll see down here as well, after I figure out, all right, here's my new velocity that I want to figure out here. Here's my local velocity based on my joystick, right? So, or my axis. And my axis is going to be, okay, x is going to change according to the axis, but y is just going to remain whatever it was. We're not going to modify y. We're just use the same one. Okay, it's important that we don't just set it to 0, because if we happen to be falling or jumping or doing something like that, we don't want to modify it. We want to let it do its thing. Okay, that's why we just pass that normal velocity y value back to it here. Right? So that's why the new velocity is the value of the horizontal axis and the existing y velocity. All right, now we say if the player is touching the ground, if that circle at the feet of the player is touching the ground, we're allowed to change the velocity somehow. Okay, which in some cases will just be, all right, I'm allowed to go ahead and apply the joystick, the axis, the horizontal axis to that. So I'll just go ahead and assign that. That's fine. All right, so now my left and right motion will be handled by that. And based on that, I will also change the animation, or at least tell the animation about the velocity. The velocity, it's going to flip the x of the renderer, the sprite renderer, so that it faces the correct way. And it's going to tell the animator about the absolute value of the velocity, so it can decide, is it idle or is it running, right? So you have those two things. Now, one more thing. It says, okay, if you're grounded, you're also allowed to jump, right? So potentially you might jump. No, the jump is handled by this key down of the space key. So we say, okay, if you are grounded and if the space key is pressed, we're going to go ahead and apply a force, an upward force to the rigid body of the squirrel. So transform.getComponent rigid body 2D, add force, and we're going to add it in the up direction. We're going to say, okay, wherever the squirrel is facing. In this case, it's usually just going to be up, but we're going to do it based on where the squirrel is, just in case the squirrel happens to be able to walk up a wall or something like that, and it was rotated, maybe. So we're going to add a force of 5. We're going to multiply that, so 5, and we're going to make sure that that force is applied as an impulse, right? So it's a one-shot. It uses its mass. One-shot instantaneous application of that force. It's not over, spread over time or something like that. So just a one quick jolt gives us that bounce, that nice force. So that's the jump. We'll call it jump if space pressed by adding force. We'll call it upward force. Okay, that's what happens there. And here we're saying apply axis-based horizontal-based motion. Okay, that's what happened there. And we have this part where we're telling the animator to do the right thing, and so on and so on. That's what it is. That's all there is to it. So welcome to using grounded. Now, there's lots of ways to do this. In past classes, I did some more elaborate things where we had, multiple colliders. You could have a collider that's at the feet, or a trigger potentially, a trigger that's at the feet of the character, and then say, okay, if that trigger is collided, then maintain some state. And you can get into all sorts of exciting things with, very elaborate colliders if you want. But this is, a pretty straightforward way. And since we're kind of time pressed this semester, let's just do this one. So enjoy. Hopefully it will be handy if you are doing a platform type game, or if you want to restrict some sort of motion based on whether or not the player is in contact with some particular layer or some particular collider that is on some particular layer. Have a great day.